All right, how are we doing, everybody? My name is Nick Clute. I am the business development manager for Turck out of Michigan and Northern Ohio. And I was sent something very interesting in the mail. It is a Shunk IO Link electronic gripper. And I thought we would take a look and see how that gets implemented with a Turck IO Link Master in Allen Bradley RS-Logix. So this will work in any RS-Logix 5000 or RS Studio setup. So yeah, we're going to be going through this here. So what I've got is I've got the electric gripper. I've got that plugged into a Type B IO Link Master. This is a 5-pin cable. What a Type B IO Link Master is that it allows for output power to be on pins 2 and 5, which it shows on these green lights. So this side here is the Type B. I've got my output power run through this disconnect. So if I shut this off, then you can see that all of my Type B powers turn off. I currently don't have the IO Link turned on right now. So what I wanted to do is I wanted to do this from absolute scratch. You can see my screen here. I've got a completely blank project. So we're going to go offline there. We're going to open up Turck Service Tool. This is the #1 way to find a Turck device on your network. It can see any device, even outside of your subnet. So what I wanted to do is I wanted to factory reset this device. You can see that it's going to get factory reset because all of the IO Link masters are going to re-enable each other themselves. And so most of them are going to have errors because it's expecting an IO Link device, but nothing is connected. You can see that we actually have an error on the gripper. That's part of the state machine of the gripper itself, but it is blinking, which means we do have good communication. It just means we got to figure some stuff out. So we're totally factory reset at this point. I want to set my IP address of this device. So again, we're going to use my Turck Service Tool. We're going to set this to 200. One of the things you'll notice is down here underneath this cable, this one, I've got a bus light that's currently blinking red and green alternating. That just means it's not ready for PLC communication yet. But as soon as I set my IP address, that's going to go to a blinking green, indicating that we're ready for PLC communication. And you got a red light right next to it. That's an error light. That just means that's because we've got all these ports that are expecting IO Link devices. And nothing is connected. So let's go into the Allen Bradley. We've got a number of different ways that we can do this. But what we like to do at Turck is we like to use what's called a catalog file. A catalog file is nothing more than a standard project that we send out at the same zip file as the EDS files. And what this does is we have every single one of our block devices pre-set up as a generic device. And there's lots of benefits for this. From version control issues and everything else. But the biggest thing is that it's going to allow me to have, especially for an IO Link device, it's going to allow me to have all 173 words labeled when I bring it in. So check this out. I've got my L4-8IOL, which is my hardware over there. I'm going to drag it over to the project that I want it to use. And this is going to be kind of real time at this moment. So we'll wait for Allen Bradley just a little bit. All right, drop it in there. And now we're done with the catalog file. And we can go ahead and we can name this device however we like. I'm just going to leave it as the 8IOL, but you can name this Op10 IO Link or whatever. It doesn't matter. You can see that it pre-sets up all of the input and output and configuration assembly instances and sizes. We do connect no matter what size you give it, but it is nice to have it correct right out of the box. So again, I set it to 200, and effectively, I'm done. If I was to download this, that bus light would go green, we'd have good communication, and everything would be hunky-dory. But one of the best things about configuration tags and Turck and IO Link and all this stuff is that all the settings that you need in order to set this device up can be done directly from the PLC project. That's one of the benefits of the generic. So anything that you can normally set up through a web server or Pactware, if you're familiar with that, we can actually do it right here from the C data. So the biggest thing right now is I want to get these red lights shut off, right? So if I take a look, right now they're all set to zeros, which is IO Link without validation. If we disable IO Link, it just becomes a digital input, which means that I need it to be set to 10000. So here we go. And so that also ends up being a hex 8, right? So what I'm going to do is I'm actually going to copy that, and I'm going to put that on all of the ports that are not my shunt gripper. Come on. And what this is going to do is every single time that the Allen Bradley PLC, so port 5 is where my gripper is, so we're going to leave that one alone. Every single time that the PLC connects to a device on this IP address, all of this C data is going to get sent down. And so that means that if you have a device replacement situation, if it's going to automatically send down and set up all of your master configurations properly. Anytime that the Ethernet cable gets disconnected, anytime that this were to power cycle, if you were to even inhibit and uninhibit the module from the tree, that would even do it. So, all right, so that is what we've got going on there. So I want to just download this just to verify that my bus light goes green and all of those red lights go away. And then I can start working on bringing in the add-on instruction for the shunt gripper just to make the process data a little bit simpler. So like I say, as soon as we see this go green, you're actually going to see all those red lights turn off. That should happen even before we get the run mode going on the PLC. There we go, look at that. So we got the error light turned off, the bus light goes solid green, everything shuts off except for the shunt gripper, right? So we left that on, and that is good for the moment and communicating. Allen Bradley is just finishing up what it needs to do in order to go back into run mode. Just finishing up what it needs to do in order to get back into run mode. All right. So as with any IO link device, right? So what we can do is all it's doing right now is it's just transmitting all of the process data, right? So it's got cyclic process data and acyclic process data. And for the most part, all we're ever going to need to use for a lot of devices is going to be cyclic process data. So if we take a look over here, this is going to be where the data shows up. I wonder if I turn this. Yeah, there we go. So we get data. So every single port here is pre-configured to have 16 words or 32 bytes. That's the maximum amount of data that an IO link device can have. And if we go into the documentation for an IO link device, right? So for instance, for the shunt gripper, if we go into the documentation for the shunt gripper, we see that we've got, let's see, we've got 2 double words, or yeah, double integers. We got 4 words, you got 8 bytes. So that means that if I were to go back into the PLC here, it's going to be these 4 words, and we've got data in the bottom 2, and if we saw, this is actually going to be our position. This is going to be our actual position, and then we've also got some status up here. So the real trick of the deal is, how do we make that data mean something? How do we make sure that we kind of tie that in? The easiest way that I found to do it is just to build an add-on instruction for it. So I've went ahead and created an add-on instruction for this shunt gripper in order to evaluate that process data. So we're going to go ahead and import that. I think what it is that I've noticed that my virtual machine has a tendency to slow way down when I'm using my camera. So everything works great when I'm doing my testing, but then as soon as I pull up my camera here, I end up with a bit of a bottleneck. I don't think it helps if I just send it away. We'll see. So we'll import this. Let's see, we're going to create that. Yep, everything looks good there. So we'll go ahead and import. import. So I think the first import was creating the user-defined data type that I use. And then the second is the add-on instruction here. So, all right, so now we've got our add-on instruction for the electronic gripping. Let's go ahead and go to our main routine and let's get it in there. So we're going to add a new line. We're going to start by doing a copy. So we're going to do a CPS or a copy command. What this is going to do for us is this is going to allow us to bring the data in and send the data back out to the controller tags for the IO-Link master. We could build the add-on instruction so that this wasn't necessary, but the thing is that by doing it this way, it's not tied to the specific IO-Link master. It's not tied to the Turck. It's not tied to the TBEN-L. You can use this with any IO-Link master and any IO-Link master from Turck as well. So we're just going to have a couple of copy commands in there, and this is probably the biggest gotcha when utilizing the add-on instructions that I've been building recently. So what we're going to need to do is we're going to need to know where our data is coming from again. So we'll go to our monitor tags. We need our iData. Where is port 5 iData start is the question. Okay, iData 67. So we're going to go over here and we're going to say, okay, iData 67, that is going to be, and we're going to leave that blank for now. Okay, so we're going to do this. And now this is where we need our O data. So we'll go ahead and go check where our O data is. Sometimes it's the same, sometimes it's not. Just depends on the master. I'm pretty sure that this one is going to be one off. Yep, so output data 066. So we've got that. Go back over here and we want to be able to copy that into. All right. And then what we want to do is we now want to call our add-on instruction, right? So we're going to go Alt Insert. Nope. Okay, we're going to add a ladder element. We're going to type shunk. All right, we're going to give this sucker a name. So what gripper is this, right? So we're just going to name this gripper, but you can name it anything you wanted. Process data in. So we're going to go gripper process in and gripper process out. Okay, now we play the Control W game in order to set all this up. So what we're going to do is we're going to say process in. We want to bring that in there. Process out. We want to bring that over there. And these copies. So what this is this is the length is in destination data types. So I want one of the process in, and I want 4 words, right? Because that was the size of our process data for our shunt gripper, and we're always in destination. So because this is an integer, we need 4 of them. Because this is in my custom user-defined data type of shunt process data, we only need 1 of those, right? So then what we do is we're going to do Control W, and it automatically fills in the right data type that we need. And look at that, it takes care of a lot of the errors there. Goes in here, fills in the data type that we need there. And here also fills that in, and now our error should go away. Boom, look at that. So that's it. Now our gripper is all set. We will be able to use that. I'm going to do one more thing though, because one of the things that this gripper does is it needs an execute command function, and it's just hard to keep typing in the execute command. So what we're going to do is I actually have a sensor right here that is, you know, I showed it right here. So I've got a little capacitive sensor that's going to turn that on. So that's on LED 6. So we're going to go into here. We're going to go into the DI input. We're going to go into IOL 6, right? Because when we disabled the IO link, it becomes a digital input. So we're going to use that. We'll go back to our main routine, grab this, put that in there. And then what we're going to do is, because we have the version of the instance of the add-on instruction is gripper, so I'm going to actually tie this right to execute command. And there we go. So now we should be able to download this. So while this is downloading, one of the things that I'll mention is like we did talk about, with IO Link, it's pretty common for a lot of times you expect to need to use an IODD file or something like that. With the Turck IO Link master and with the fact that most IO Link devices we only need to be working with the process data, you actually don't need to have the IODD or a tool in order to do that. With the Turck IO Link masters, what we do is we have this tool called Pactware. This allows us to go in and actually search for each device. We can install the IODD files. You can it'll break it all down for you. So the process data structure is all built in here. It tells us exactly how many bits, bit length 64 and all that. And what our add-on instruction is going to do is it's going to break it all down into this for us with all of these names. But the other thing that's kind of nice is that I am able to go in here and connect to this and then transfer the process data. There we go. Now I can go through and transfer the process data. So then I'll be able to actually see that everything is working the way that I expect. So our Allen Bradley is up. Let's go ahead and run that. So the one thing that I'll look at here is this execute command. Remember, that's tied to my sensor. So I'll turn on the sensor and that becomes true. Let's bring up the camera. So I've got my here, that's false. If I pull that in, next time scans goes to true. Let go. Execute command goes to false. Excellent. So we know everything is kind of running. We have that capability in our back pocket if we need to check on something. So now let's play with this gripper actually. So the way this gripper works is we've got this command structure. So inside of the documentation, the biggest commands that I'm going to be working with is the acknowledge command. So once I do that, go over here, I know that it worked because the status went to 3. So anytime that the status goes away from 0, we know that we're good. So now status is 3, so now I can do a reference, or basically a home. That is function 2. So when I do this, you're actually going to see the gripper move. That's going to go find its end stop. There it is, nice and slow, finds its end stop. So now we're getting a referenced. So that works out great. So now we're good to go. We can make this sucker grip. And we can make this sucker release. Look at that. Beautiful. And that's all there is to it. So basically we can set up the 8IO link using the catalog files, Turck service tool to set the IP address. We've got the add-on instruction that you can use in order to bring out the AOI. AOI allows you to bring in the process data. That's what I'm looking for. And from there, now all of a sudden, now all you need to do is just use the gripper dot commands, and you'll be able to set any of this data that you want. You'll be able to change the command inside of a state machine, inside of your ladder logic, whatever you need. So yeah, the only other thing is we're in the grip position. So if we go and we release this, right? Go release this. The gripper itself is actually, it's not holding itself there, which is fine. We can also do a target position. So this is a real number. So if I go to position number 3 and I do a guided move, it should go about halfway. Yeah, there we go. And when you do that, now it's held. All right. This works with either command 4 or command 5, anywhere where it's going to be holding a position directly, right? So not release, but it's going to be holding the position. Now, if we go ahead and shut off output power here, and we see that, remember, our type B power supply shuts off, now this gripper is back and in a safe position, so it's not going to hurt anybody. And that's it. So thank you for watching this quick video. If you have any questions, the add-on instruction should be available wherever you're watching this video. And actually what I'll do is, just in case you don't have the add-on instruction available, all the process data breakdown within Allen Bradley for any IO Link device really can be done with just a couple of commands. So we've got bit field distribute. This allows you to grab a couple of bits from any words or any parts of the controller tags. What I'm using it here for is I'm actually having to do a word swap in order to get it in the right orientation in order to make it a real value. Then down here, obviously, I've got my digitals, so I'm just able to use dot notation in order to grab individual bits from that. Here's a BTD that is grabbing the workplace bits. Here's the status. So if we take a look at the documentation itself, right? So if we go here and we find our process data incoming, our status is actually going to be on word 0, bit 8, right? So what we're, and it's only 3 bits long. So that's what we're doing here is our source bit is 8 for 3 bits long. We're going to take it from the process data in dint0 and dumping it into a variable called status, and then we can, and then that's just going out of the AOI, and that's pretty much it for grabbing that data. So you can go ahead and I'll scroll through here. Here's the output data. So what I'm doing here is on the output I'm doing a BTD, sending it into a dint, and then at the end I'm just ORing it with everything, and then eventually sending it out to the output data. And then after I do all those ORs, and then that's when I give it the 2 bits that I need. And then here's the target position going from a real value back out to the double integers that it needs. So we'll go ahead and scroll up nice and slow so that in case you have to build this from scratch, you can do that. And yeah. And again, if you have any questions, feel free to reach out. My name again is Nick Clute with Turck. Thanks, and have a wonderful day.